Hello.
Hi, James.
Hi.
You caught me with that background, but I always see these like spaceship wires or whatever, and I'm like, this guy.
It's Millennium Falcon.
Oh, okay, right, okay. Yeah.
Not here.
Hey, Jan.
Hey, how are you?
Yeah, I'm good, thanks. And you?
Very, very tired. Next week I will be on vacation, luckily. So good for me. This week I attended Dreamio Subsurface conference. I presented there also. So it was quite exhausting. I mean, the preparation and everything around.
Oh, yeah. That's difficult. Was it in Europe? Was it online?
Yeah, it was online.
Oh, okay, yeah.
Or not sure if I get your question correctly.
I was just wondering if you physically traveled to a conference in somewhere other country.
I see. No. This conference is still fully virtual. No one travels nowhere.
Yeah.
Actually, it was quite tough for many people to focus on the conference while we have war in Europe, you know.
Yeah, I've struggled with this a lot. Just I keep going back to Sky News, CNN, whatever, flipping between these, even making myself more unhealthy, I think, by watching too much news. And yeah, it's something that like stays in your head every hour of every day. It's terrible.
Yeah. So first thing I do in the morning when I wake up is to check news if the president of Ukraine is still alive. And you know, it's really where now COVID seems to be like no big deal, you know.
Yeah. Yeah. I mean, I'm sure in Ukraine, nobody's checking whether you got your mask and sanitized your hands.
Exactly.
Yeah. Okay, I don't know how many more. So I've been speaking with, probably many will know, Vitaly, Vova, and maybe fewer of you will know Anton, but they're all Ukrainians who work with me in my team. So I think that's also why I've been struggling so much with this thing, is because I personally worry about them. But they're all okay. They cannot leave Ukraine. But they sort of in different areas, and they even able to get online and join calls quite a lot, or do bits of work. So some of them may even come and join here, but I'm not sure. And they said they can't promise anything. So maybe we'll end up with just a smaller group today, which is okay. Maybe Charles will come from our side. I've just checked in to see if he's around. sometimes he loses control of his calendar. But otherwise, I think I'm just going to start us off, and we can.
Can anybody hear me so far?
Yes.
Yeah.
Yes.
Oh,
Yes.
okay. That seems my microphone has some problem just now, so I fixed them right now. So nice to meet you guys.
Nice to see you again. Yeah, so I mean, really, it would be nice to have our bigger group and all the people who made this possible here. But one of the announcements, obviously, that we finally got Drill 120 done. It took quite a while, and there were a lot of regressions that we solved in the release candidate phase. And thanks to everybody who also, helped finding these issues rather than we released with them still present. And we even ended up fixing some things that had been there for a couple of years. So, that's really good. It's genuinely like a better drill in that sense, in the fixes sense. And then, of course, there was new features and all of that sort of thing. So I think Drill has never been through 6 release candidates before. So I now have this badge of honor. I don't know if anyone will take it away from me. It feels like I've got a record that will probably stand. And it was quite tough. It takes quite a while to build a release, just the slow process with Maven and whatever. And yeah, even the script to do that needed a little fixing. And then, of course, we did this Hadoop 2 build, and there wasn't really an obvious, simple way to do 2 builds inside a single release using the Maven tools we have. So it ended up being kind of 2 releases each time there was a candidate. So it was kind of like 12 of these things that I prepared. And then somebody would pop up and be like, "Hey, James, there's a bug." And I'd be like, "No, I never saw that." But I think we got, we pushed through all 6 of them. Hey, Charles, welcome.
Hey.
And we've got a good release done. And Jan is actually just helping me figure out some complications that have popped up in the Docker images, because in order to improve security inside there, we stopped running as root, drill as root inside the container. And now there are permission problems with regard to accessing data volumes and areas where drill needs to write, embedded drill needs to write storage configs and that sort of thing. But Jan's quite familiar with this stuff, so he sent us some ideas. So that will be something we can fix soon, I'm sure. Yeah, so that is the one big announcement. And I know Charles actually, yeah, it was when just recently announced Wang Tengfei to as a new committer. So that's always a good bit of news, and we're always happy to grow the community. And then maybe I'll just say something briefly now. Charles, before you joined, I was just mentioning, that we had some news from our Ukrainian community members, and they're all fine. But obviously, we are thinking of them all the time, and really, yeah, worried about what's happening in Europe. I think that was kind of those of the announcements I can think of. So, and I know that we've got a presentation, I think, scheduled for. Let me just catch up here. Yeah. Okay. So I think Wang Tengfei has offered to discuss the real-time data warehouse that he's architecture that they've built on Drill. So if I've got my aliases and names right, and that's the same person as Leon, then that would be great.
Yes.
Yeah. Okay. Thanks. Well, welcome. And let me just say welcome. Thanks. Great to have you in the team as well. Let me hand over to you.
Oh, okay. So I will share my screen. Okay, I will try to. Okay.
Do you need any extra permission or anything?
Yes, I think I will try to give some permission to Zoom to share my desktop, I think.
Oh, okay. Okay. Well, let me know if there's any permission I need to give. I actually can't see a place to do that though. But I think
Are you the host? Are you the host, James?
Yeah, I think I am. But I did
Okay.
go into Zoom, and so I connect to Zoom from a browser, which
there we
means,
go.
Perfect. It's working. Yeah.
Okay, so so you can see my screen, yeah?
Yeah, we can.
Okay, okay. So this is Tengfei Wang, the new committer, and I'm coming from China, and currently work for Alipay, and we have a app which has more than 1 billion user, and also our team built the one real-time data warehouse to do the OLAP analysis in our company. So this architecture is currently version 2. Before this, we have the version 1 is with the Drill and Druid. So for the version 2 is Drill plus ClickHouse. And currently we are working on the version 3. I will mention it later. So for the version 2, I will start from we have first one layer VIP. So the client, the user can connect us by using the normal MyCircle JDBC driver, and we add the COBA server before Drill. If you have heard the COBA, it is also a open source project. I think it is created by the Alibaba. So the user can talk to our system using the MyCircle wire protocol. The COBA server and the drill bit, it is in the same process. So the user can connect to the COBA server using the MyCircle driver, and they talk using the normal MyCircle wire protocol. The COBA server, first we have the simple parser. It can tell it is a query or insert or create a comment. If it is a query, it will submit to the drill bit. This is the drill bit. Yeah, we separate the drill bit in 2 rows. One row is dedicated for the foreman, and it will submit other fragment to another row as the compute row. So we separate the two row. For the foreman, it will do the planner, and also only the first fragment. They are the intermediate fragment, and the leaf fragment will be sent to the compute drill bit. Okay. And also for the compute drill bit, we separate them to different group. The link between the user and the group is stored in the MySQL. So for example, we can have a public group which has many drill bit node, but for some user, his query is very important. They want to use dedicated resource, so we can create another group and link the user and the group, so they can use the dedicated resources to do the compute. But normally we will push down the heavy compute to our ClickHouse cluster. So here we have our ClickHouse cluster. It is also grouped by tier. So different user can have different tier. So means different resources. For example, for one tier, we can have for one table, we can shard them to different shard, and also we have a replica. And also we have a metadata manager cluster connect to the same ZK with the ClickHouse cluster. So it has the distribution information of the table. The metadata is cached in the how to say in the foreman drill bit process. So this means one process. So we have many process like this. They will connect to one VIP. So it will the query will be balanced between different drill bit. Also for the compute drill bit, they will connect to another ZK. So the foreman drill bit will discover the compute drill bit by the ZK. Okay. For the insert and update command, they will be sent directly to the ClickHouse cluster. And also we have the one KV persistent store to restore the result cache and profile. So if we have the exactly same circle, we can read directly from here from the result cache. So this is yeah, okay. And also we maintain the user for login in the MySQL in the my circle. And also we have the cluster administration functions, such as we can ban some circle, and also we can ban some table for query or ban some table for insert. We separate the drill bit for format and compute for the reason that the insert will make the heavy GC. So we separate the two rows. So the compute will not affected by the GC. Okay. Yeah, currently the basic architecture is like this. So the big view is we have one layer for one layer is the drill layer to connect with the user and do the plan and parallelize the and create the fragment and parallelize the calculation. And also we will push down as we can to the calculation to the ClickHouse cluster. So normally it is as the scan fragment.
We just lost audio, I think.
So is that
now we can hear you, I think. Not anymore.
Okay. Yeah. Wang Tengfei, we lost sound.
Can you hear me?
Now we can, yeah.
Okay. So normally we have two big cluster as this. For the drill nodes, we have 160 nodes and 90 format nodes and 70 compute nodes. And for the ClickHouse nodes, we have more than 800 nodes. And normally we have 200 million TPM for the insert and 80,000 RPM for the query. And for now is 99% is less than 1 second. I think our use case is not the typical drill use case, I think. Yes, but it did give us a solid base to build our system.
Really interesting. And I've got a question, if I can quickly ask a question before you go on.
Mm-hmm.
The queries get routed through drill and then pushed down to ClickHouse. Why didn't you just send the queries directly to ClickHouse here and cut out drill completely? Were there some other data sources as well?
Yes, I think there are two reasons, I think. Because back up to, I think, 3 or 4 years ago, ClickHouse don't have much distributed table capacity. So we use ClickHouse just as a local compute engine. and we use drill to do the distribution for ClickHouse. And also, I think even for now, ClickHouse, the planner of ClickHouse is not as good as drill, I think. So we extend a lot the rules, the push down rules. We made a lot of rules in drill to former give a better plan, to give a better plan for the query. So you can for the version 1, we use Druid as the local compute engine. For version 2, we use the ClickHouse. And for version 3, we are currently developing our own local compute engine to replace ClickHouse. I think it will faster than ClickHouse.
My word. Wow.
And
okay.
And do you plan to open source your engine?
I don't. We are developing it, and I think in the future it will be open source. I think, but not sure yet.
And it will be also distributed like ClickHouse, or it will be local compute, and the distribution will be managed by Drill.
It will for now it is only local. It is only local compute engine, and we also use Drill. I am not sure. Maybe in the future we will add the distribution capacity in the new engine.
And my last question: what is your experience with how well Drill pushes down certain operations into ClickHouse? What operations can you observe are pushed down into ClickHouse?
For now, almost I think except for now, I think except window function, all other operator will be pushed down. If the condition is met. For example, for the join, if the two tables have the same distribution condition, we will push down the join to the ClickHouse. We mean local join. So, but they have to the same number of shard, same column to use to sharded the table. So we can do the local join. So we can push down them. And also for the aggregate. For the aggregate, also we have the group by the shard key, so they can be pushed down.
Okay,
that's really interesting. Okay, so because I think I've just remembered now that ClickHouse can't always do big joins. It can do small joins. It needs to put everything into memory from one side of the join, or you need these special kind of conditions, I think, like we've just been describing. So that's actually, I could now kind of understand what Drill maybe brings to the party that ClickHouse couldn't do, at least when I was looking at it 2-3 years ago, where you could do bigger joins, for example, or unexpected joins, columns that weren't planned for.
Yes, if we can, because for one table, if we can shard it, for example, by 20 and 40 nodes, so each local table is small.
And by the way, do you also store small tables into ClickHouse? I mean, for example, dimensional tables. Do you store them into the ClickHouse as well? And if yes, how do you shard them, if at all?
There is two options. One option is it is sharded as the other table. For example, we have one dimension table and also the fact table, one small table and one big table. So the big table, for example, it will be sharded by 100 nodes. Also, the dimension table will also be sharded by 100 nodes. And they will be sharded by the same, by the column which will be used to join.
Yeah, I see.
And
well, the problem, from my experience, the problem is typically when you have multiple dimension tables and one fact table, you have multiple foreign keys to each dimension table, and you don't know how to shard the fact table, if by this dimension or another dimension. So what do you do in this case?
You mean we have a multiple join key, right?
Yeah, exactly.
Yes, in this case, we do the join by drill. Yeah.
Makes sense. Well, what I know from other database engines, in this case, typically dimension table is not sharded, and a whole copy of dimension table is stored on each node in each shard. So you can do local join anytime with any table. And you can do this with small dimensions only, obviously.
Yes, I think we have one dog for this case. Okay. I think we recently, okay, I will try to, yeah, bucket shadow. Oh, sorry, it is written.
So I think you share only your browser and not the another window.
Okay.
So
yeah, I will find the doc first. Okay. Okay. Yeah, I think, yeah, okay. Yes, this is done by drill. Okay. Oh, yes. I think there's another case in the table will be resharded by the shard key of another table, and will be sent to the data will be sent to the place of the other table.
oh, I see.
Mm-hmm.
Everyone solves this issue similarly.
Yeah. Okay. I think for now is drill don't have the result cache, right?
Yeah, that's true.
Right.
And by the way, what
Yeah.
technology do you use for this key value persistent store?
Yes, it is the self design engine.
Oh, I see.
And
Okay.
also, this KV persistent store will be the base of our new local compute store. So our new local compute store is one layer on this KV persistent store. So the data can be stored once, and it can do the KV query and also the OLAP query. Yeah.
Just with the results caching in drill, obviously because drill has these completely external storage plugins, it doesn't know too much about what has or hasn't changed in any given storage that's connected. So caching is quite tricky in this situation in the sense that you know, because you don't know whether anything's changed, you can easily serve stale results. So it often feels like it's better for a layer in front of drill, which is able to encode some rules about what is acceptable to it for staleness of results to do the job, rather than to try to put it in drill. Well, that's what I've kind of thought so far.
Okay.
Versus something like, you know, a simple database, or say simple, but a database that does its own storage, like let's say MySQL. It knows every change to every table. I don't know if MySQL has something like materialized views, but it's quite a similar sort of story there, where the DBMS is, because it controls the storage of the data and it's got visibility, it's able to know when it needs to rematerialize the view or not. Materialized view being kind of like a cached copy of results.
Yes. For us, we have one circle hint, to control the cache time.
Yes, yeah, exactly. So often that if you have a business rule or something where you know the problem domain, so you understand your data and you know that it's acceptable to serve data that's 10 minutes old to this query, then you're in a good position to use a cache. But you know, drill can't know that kind of thing, if being general purpose. And there could be somebody else's application where if you serve data that's 5 minutes old, it could be ruinous, you know, maybe completely ruin the application or something. So yeah, this is where this cache lifetime thing gets tricky.
Okay. Yeah, I find it is very difficult to build a general engine. Yes.
Yeah, this is why I think it's, you know, what you've done by putting a cache further forward in front of drill, one in which, you know, you can encode the business rules that you know, make sure that that cache is fresh enough for the application, is probably the right way. I mean, maybe drill could provide some of the infrastructure for people to do that. It provides nothing at the moment, so, and it could be at least just configured from outside. But yeah, for now, people have to cache themselves completely outside on their own.
Yes, but our KV persistence store use the drill persistence store interface, I think.
Oh, okay. Okay, that's interesting. So it's kind of integrated into drill to some extent.
Yeah, yes.
Okay, okay.
So this drill bit can decide if it should collect data from this persistent cache or it should ask drill computes to calculate it. Am I correct?
Yeah, yes.
Okay, okay. Sorry, I was a little bit, I didn't pick up on the fact that the cache is after the foreman has already received the query and started running. Okay, that's really interesting.
Also, it will store the profile, the drill profile.
Right. Yeah. Yeah. Really interesting architecture.
And by the way, how do you invalidate the cache? I mean, there are insert updates going directly into ClickHouses. And in certain point of time, you have to invalidate caches so you get newer data. How this is processed?
There are two options. For one option is just time. By default, it is 1 minute. Because normally for the OLAP analysis, it is not quite real time, so they can accept it. Also, they can change the time by the circle hint. They can add one circle hint to define the time. And also there is the second option is for the offline table. So we have the type of table that is the data is it is load one time per day. So the cache will auto invalid when the load finish. Yeah.
And do you invalidate a whole cache every time, or can you invalidate only part of the cache based on what tables were changed?
For the time, it is for the option one, for based on the time based, it is per circle. And for the option two, it is per table. Yeah,
I see. And one more question I have. These insert update processes, they typically insert or update one table. Am I correct?
Actually, it is depends on it use the metadata. One table for our system can be sharded to 3 tables for the ClickHouse. So the insert circle will be divided to 3 circles. Each one will send to the dedicated ClickHouse.
And what about the consistency? I suppose that these 3 inserts into 3 different ClickHouses can be handled in single transaction, or can be?
I think there is no consistency guarantee yet. Yes, and we have 2 types of table. One is append, so the data is just append to it. And also we have update table, so the new data will replace the old data.
Okay, I'm just thinking about joins. Yeah, when you join 2 tables and one table contains newer data and second table not, then the join can be inconsistent. So my question is, how do you handle such situations? Can it happen at all in your use case?
Sorry, can you repeat your questions?
Yeah, so there are multiple tables in ClickHouse clusters, and they are refreshed or appended by different processes. So it can happen that one table is updated and second table not. And when you join them, the result can be inconsistent, yeah, because some data are still missing in the second table. Can this happen in your use case?
You mean the
For
different...
example, you insert new facts, but you are still missing dimension records, corresponding dimension records. Can this happen in your case?
Sorry, I missed the second.
Yeah, so you have two tables. Let's say one fact and one dimension, and through these insert processes, fact table is populated, but they are missing corresponding dimension records because they haven't been populated yet.
Okay.
Can this happen?
Yes. We don't have the consistency between different tables, I think.
Okay.
Yeah.
I just want to quickly ask one question back about the caching and the SQL hint. Was that something that, did you add some new grammar? Where does the SQL hint end up going in the syntax?
I'm not sure it is in drill, in the communicated drill. Do we have the SQL hint capacity? I'm not sure it is if we add it or it is already there.
Oh, okay, that's a general, okay, so there's a general SQL hint sort of that you can find across a lot of dialects, and I've never seen it in drill. But there is stuff, you can provide quite a lot of extra information beyond just standard ANSI SQL, like stuff for format plugins and configuring them using table expressions. But yeah, I'm not sure exactly where the cache hint could go, but maybe you just
yeah, I think it is the standard SQL hint. We pass it and add it to the session option, I think.
Okay, all right. So then, okay, there's some syntax I didn't even know. That's pretty awesome. That's great. Yeah.
By the way, did you need to extend ClickHouse plugin, or did you need to extend drill in any way to improve ability to push down into ClickHouse?
Yes, we built a new plugin. It is the dedicated for the ClickHouse. I think it's totally new. I think it is a new plugin.
Yes, so this is new drill plugin, right?
Yeah.
Yeah. So you didn't need to extend call site.
We didn't extend the call site. Yeah. But we add the CBO information. Yeah, I think.
So probably still new rules that you still would have programmed against the Calcite API and added rules and that sort of thing, but never had to change Calcite itself.
Yeah, yes, Nick. Drill can get the rules from each plugin, I think. So we add the rules for the plugin.
Yeah.
Interesting. Because we personally in my company, we extend Calcite by specific SQL dialect, specific SQL grammar, and then we can generate SQL which is valid for particular data source, like for example for Redshift or Snowflake, and we can be sure that it will work. For example, in Snowflake, so we can push it down. Yeah. And because Calcite dialects are poor, so we extended them a lot, especially in the area of date arithmetic, for example. So you can push down group by date truncate of week or something like that. That's possible because we generate specific date grammatics dialect for example, for Snowflake. So that's the way we go.
Okay. So you mean for one circle you can generate different dialect for different data source, right?
Exactly.
Okay.
From what I remember, ClickHouse's SQL is not really that much like standard SQL at all. It's almost slightly different language.
I thought that this is the situation, but when I reviewed latest documentation of ClickHouse, I was very surprised what they achieved in the last 2 years. Now almost everything is supported in ClickHouse, so it's much better than it was.
Yes, I think we built this system. I think it is 3 years ago, I think. Yes, we also change some dialect for ClickHouse also.
And do you plan to somehow push it into upstream?
To what?
To upstream repositories, for example, into Drill or even into Calcite, if you plan to contribute in any way.
Yeah, periodically I pick something it is general to the Drill, I think.
Okay.
Yeah, I mean, that's an interesting, because I think we've just made the generic JDBC storage plugin compatible with ClickHouse, and presumably only partially compatible. I don't know what happens if you throw every bit of SQL you can at that. So I think that's, all that open source Drill has is a chance to try to connect with storage JDBC and support some queries with the JDBC storage plugin.
Yes, I add the ClickHouse capacity to the JDBC plugin. Yes.
Okay. So, but that's not what you're using in this architecture. Have you got your whole specialized plugin for this architecture? I think so.
Yeah, yes, because this architecture will need the metadata, the metadata information about the ClickHouse cluster.
Right. Okay. It's because it makes decisions based on, and some of that stuff may not necessarily be general enough to merge back into drill.
Yes.
Not that I know, but yeah. Yeah, well, we always welcome, if you do find something that seems like other people could find useful, it's always welcome.
Yes, I'm always try to find something general to contribute to the open source drill. Yeah.
So I think the question is if the way you are sharding in ClickHouse, if this is something what could be generalized. So do you know about any other projects which are sharding similarly like you, or did you inspire yourself from other projects how to shard ClickHouse?
I'm not sure. I think it is the common way, I think.
I mean, if the way how you shard is common, then your plugin could be reusable. That's my idea.
Okay. Yeah, just the problem is for the ClickHouse, there is no leader role, I think, to get the information about the distribution from ClickHouse directly. Yeah.
So you need to have some kind of custom metadata layer, like you have here.
Yes, because how to distribute the table is controlled by our metadata cluster. Yeah. When you create table, yeah. Because the create table is controlled by our system. Yeah.
I see.
Right. Well, it's really cool. I mean, it's the biggest drill cluster I know about, so I think that's pretty cool.
And by the way, just out of my curiosity, how much data is stored in your ClickHouse clusters?
I haven't calculated that. I think it at least PB, I think.
And ClickHouse compresses a lot.
Yeah, it's columnar storage like in other cases. So I don't know what type of encodings they support, but compression should be good, at least.
Yeah, I think I will also add many UDF like the bitmap, and also the cube to do the pre-aggregate. Yes.
Cool.
Great presentation. Yeah, really, really awesome. Really impressive. I don't know if anybody's got anything more that want to continue on with here. Wang, Tengfei, are we at the end? We're kind of just taking questions now, I think.
Yeah.
I don't know if anyone, well, if anyone would like to ask more, please go ahead. But otherwise, we did kind of reach the time as well. So if we feel like calling it a day here, we can.
I don't have more questions. I'm going to start my vacation.
Okay, yeah. Have a good break. Yeah, and I mean the whole world is hoping for peace in Eastern Europe. So yeah, hope everything gets better quickly. Yeah, and then okay, well, thanks everybody. It was a smaller gathering this month, but it was still a really good one, really interesting. And
I think
okay, there's a question.
Has one. Okay, yes, because in our system we have a lot of insert. For example, it is 200 million TPM. So this insert will create a lot of GC. Even for the minor GC, it will take around several seconds because a lot of data go in drill. For query, drill is use the direct memory, but for insert, we just use the GVM heap. So it will create a lot of data in the heap. So it will make a lot of pressure to GC. So this will affect the compute process. So we separate them in different nodes. Even more, we have a dedicated cluster. We have dedicated cluster of drill of this process. Just dedicated for insert. This means we have a cluster of this part, and they will insert to the same ClickHouse cluster.
And by the way, how you deploy this beast? I mean, is it running in virtual machines, or is anything running in containers, or what is your kind of deployment approach?
It is run in Docker. We deploy by we build the drill and then package it in the RPM, and we have one platform to deploy this. They all run in Docker.
And these drill bit computes, they are running in cluster or not?
In cluster, yeah.
And
I
how
think it's just the same code base. Just the role is controlled by config. For the foreman, it just open the port of the COBA server, so the VIP can find the foreman, and it will not connect to this ZK. So only the compute drill bit will connect to this ZK. So the foreman can only find the compute node in the ZK. It is just a config. Yeah.
I see.
Really interesting. Yeah. Okay, well, I'm gonna drop off. You're welcome to stay. the meeting, the video recording will be, I think Hu Jing Chuan will help us again to get it out of Zoom and into YouTube. Yeah, thanks very much. It's been really great.
Yeah, thanks too, and take care.
You too.
Bye.
Thanks, and have a good vacation.
Bye-bye.
Yeah.
Yeah, thanks.
Thanks. Bye.